Well, let's explore writing an exponential function. And we have an example here that we can work through to help us do that. So it says a manufacturer distributed 3.2 million aluminum cans in 2005. Then in 2010, the manufacturer distributed 420,000 cans made from recycled cans it had previously distributed. Assuming that the recycling rate continues, write an equation to model the distribution each year of cans that are made from recycled aluminum. Well. All right, let's see. Well, we can use this form right here. Let's see. We got y equals ab raised to the power of x, where y equals our output, or our current amount, let's say, in this case, and a represents our initial amount, and b represents the rate. I think in this case it's going to be a rate of decline. And then, of course, x is our exponent. So let's kind of think about this problem here and what we got to do. Well, I know the output, 420,000, and I know the initial amount, 3.2 million. And I actually know the number of years, which would be 5 years, and that's going to be in my exponent. But what I don't know is the recycling rate. That's really what I'm trying to find. And that's B. So let's see. Let's start on an equation. And I'm going to put all this in decimals in terms of million, 3.2 million. So I'm going to say y is equal to 0.42, 420,000. And that's going to equal A, 3.2 million. 420,000 would be 0.42 million. Times B, which is what I'm trying to find, raised to the fifth power. So I'm trying to find B. I'm trying to find that rate. Well, let's see. We can take 0.42 and divide it by 3.2, and that comes to 0.13125 equals B to the fifth power. So I divided everything by the 3.2 million. And then we want to take the fifth root, and I'm going to move it over here, the fifth root of 0.13125, and that's going to equal B. And with this, I can write an equation. Let's see, the fifth root of, let's see, I need to do math. Go to option 5. We got the fifth root of 0.13125. Enter, and that equals, and I'm going to round it to the nearest hundredth, 0.67 equals B. All right. Well, now we can write a general equation for that. And it's going to be, in this case, it's going to be y equals 3.2, that's my initial amount, times 0.67 raised to the power, we're going to say to the power of x. All right, well, Shazam, that's not too bad. That's pretty cool. Let's see, I think there's one more part to this. It says, how many cans can be made from recycled aluminum cans? Can be expected. How many cans can be made from recycled aluminum can be expected in the year 2050? Well, I have to go back. Our initial information came from 2005, and now we're talking about 2050. So we're talking about 45 years. So then we can say that y equals 3.2 times 0.67 raised to the power of 45. Let's see, 3.2 times 0.67 raised to the 45th power. Let's see, and that's going to then equal 4.76, I'm going to say 77 round it, times 10 to the negative 8th power. That means I put 7 zeros. Let's see, then y is equal to 0.1234567 477. You know what? That is a really, really small number. And I'm just going to say, you know what? There's just none. There's not going to be any cans made from that recycled aluminum in 2050. Not when it's that small. What is that? Tenths, hundreds, thousands, 10,000s, 100,000s, million, billion, $10 billion, 100 billion, trillion, yeah. 477 trillions. Don't think so. None.